Hello everyone. In this session, we will try to discuss about the double pump hydraulic circuit. As the name suggests, that double pump, it means that there are two different pumps we are using it. The first one is nothing but a high pressure low flow pump. The second one is nothing but the low pressure high flow pump. These two pumps we are using in the circuit. For that reason only, it is called as the double pump hydraulic circuits. Especially these type of circuits are having a major application in the presses, in the punches, or punch press, or especially in the case of the sheet metal industries, where the sheets it has to be deformed by the application of the hydraulic forces. Now, in this a typical application is in the case of the sheet metal industries, and also in which the hydraulic ram must extend rapidly over a greater distance with a very low pressure but a high flow requirement. This rapid extension of the cylinder occurs under no load conditions. As a punch and as well as the workpiece or the tool and as well as the sheet is under contact, at that point what will happen, the load what it has to be applied for the deformation of the sheet is more. However, during a shorter motion or the small portion, when the punching is taking place or the deformation is taking place, at that time the pressure requirements are high due to the punch loads. During the punching operation, the cylinder travel is of a small, thus the flow rate requirement is also low. The circuit eliminates the necessity of having a very high expensive high pressure and as well as the high flow pump. When the punching operation begins, the increased pressure opens the unloading valve to unload the low pressure pump. Now, the purpose of the relief valve is to protect the high pressure pump from the overpressure. At the end of the cylinder stroke, and when the DCV valve is in the spring center mode, the check valve is used to protect the low pressure pump from the pressures which occurs during the punching operation. At the end of the cylinder stroke, and when the DCV valve is in its spring center mode, the entire oil what it has been collected, it will be flown back to the tank. See, this is an operation with respect to the what we can say the double pump hydraulic circuit. Now, by looking into the schematic diagram, or it may be the hydraulic circuits, here there are two different types of pumps is there. One is nothing but a high flow pump, the another one is nothing but a low flow pump. The low flow pump and as well as high flow pump is connected by means of a check valve. Now, in turn, these two is connected to a relief valve through a uploading valve. Now, in between the what we can say the actuation or the system or the actuator and as well as the pump circuit, what we are having is nothing but the DCV valve. Even in the DCV valves also, while actuating it, that it can be actuated either by means of the manually or by means of solenoid control. But here in the schematic diagram, the DCV valve what it has been shown is nothing but the manual operated only. The next part is nothing but the counterbalance wall applications. Now, the counterbalance or the back pressure valves are used to keep a vertically mounted hydraulic cylinders in the upward position while the pump is idling it. See, especially in some of the operations, normally in most of the cases what we had discussed in the previous circuit diagrams, the actuators it is placed in the horizontally. But in this, especially in this, if the actuator is placed in vertically, what will happen? Because of the load, automatically the actuator will start descending it. That descending movement, it is what we can say descending movement of the piston from the what we can say the rod end to the piston end. It can be minimized by using or by implementing a counterbalance wall circuit. A counterbalance wall is a set to open at somewhat above the pressure requirement to prevent the vertical cylinder from descending due to the weight of its load. This permits the cylinder to force downwards when the pressure is applied on the top. The open center directional control valve uploads the pump. The schematic diagram shows the what we can say the bottom portion is nothing but a tank where the tank is filled with the oil or the hydraulic. Above that is nothing but the filter. The filter is in turn connected with the pump. The pump is in turn connected with the relief valve. After the relief valve, it is connected with the DCV valve. This DCV valve is actuated by means of a solenoid one. Now, in between the what we can say the DCV valve and as well as the actuations, in between these two, a counterbalance wall is also placed, which is nothing but where the reverse flow of the oil is minimized. Once if the loading is done, at that point what will happen, the piston will start from the bottom to the top. Okay, because of the load, the piston may start descending it. That it can be minimized by using the what we can say the counterbalance wall. Cylinder synchronizing is necessary, especially in the case of the industries. That too, especially in the industries where the large mass it has to be moved, or the large load it has to be lifted, or large work it has to be done. In such cases, we are going for the cylinder sequencing. See, even in the cylinder sequencing also, there are so many different methods are there. That too, so many different methods in the sense that too, especially two different methods are there. The two different methods are nothing but the cylinders which are connected in parallel. The another one is which are connected in series. See, depending upon the type of the application and also the load what it has to be applied, or the load what it has to be transferred, or the mass it has to be shifted from one place to another, like that, even this also it is varying it. In such cases, we have to use the two or more cylinders to prevent the movement that might distort or the damages the load. Now it can be a designed as less material, and if it is pressed down with a two or more cylinder, these cylinders must be synchronized. These are of way either it may be in the case of the series or it may be a parallel. Now the first one what we are discussing is with respect to the cylinders which are connected in parallel. See, as the name is suggesting that the cylinders synchronization is in the parallel. Now here the synchronization means, as we know that we are using the two different cylinders which are of identical. Now for that reason only the two cylinders which are kept parallel and directly the load is applied over that. See that this process is called as the cylinder sequencing in parallel or cylinder connected in parallel. However, even if the two cylinders are identical, and it would be necessary for the load on the cylinders to be identical in order to them to extend in the exact synchronization. If the load are not exactly identical, the cylinder with a smaller load would extend first, because if would move at a lower pressure level. After this cylinder have fully completed its stroke, the system pressure will increases to a higher level and required to the extend the cylinder with a greater load. And it should be pointed out that two cylinders are really identical. See, here in this case, especially either we can use the two identical cylinders, or it may be of two different types of cylinders in the sense either different capacities. These two it is connected in parallel. In the schematic diagram, it shows that in the left side the lower portion is nothing but the tank. Over the tank the filter is there. The filter is in turn connected to the pump. The pump is in turn connected to the what we can say the relief valve. The relief valve is in turn connected to the what we can say the solenoid controlled DCV valve. Now from the solenoid controlled DCV valve, the two cylinders are connected. These two cylinders are kept parallel. Okay, but here even the load also what it is taking, either it may be identical or it may be a incremental, what we discussed with respect to the first one is a lower one and the second one is a larger one. See, even here also depending upon the type of the cylinders what we are using it, either if it's an identical cylinder or the two cylinders with which is of a different, what we can say, the specification, the first lower should be loaded and then the second, the higher, should be loaded. This is a procedure normally what we are, or what it has to be followed in the case of the cylinder sequencing, that too especially in the case of the parallel. The next topic what we are discussing is the cylinders which are connected in series. Even in this also the two cylinders, either it may be identical in series. It is a simple way to synchronize the two cylinders during the extending stroke of the cylinder. The fluid from the pump is delivered to the blank end of the cylinder 1 via the flow path shows the upper envelope of the DCV. Then the cylinder 1 extends. The fluid from its rod end is delivered to the blank end of the cylinder 2. This is the process what it is taking place in the case of the cylinder sequencing in series. The fluid return to the oil tank from the rod end of the cylinder 2 as it extends via the DCV valve. Now in these cases, either it may be the cylinder sequencing if it is done through the parallel or by means of the series, DCV valve is a must. The two cylinders, it should be a synchronized one. Okay, the piston area of the cylinder 2 must be equal to the difference between the area of the piston and the rod of the cylinder 1. See, this it should be maintained in the case of the series. The schematic diagram shows the, what we can say, the cylinder sequencing in series, or the cylinders connected in series. From the left to right, I am start explaining the hydraulic circuit diagram. The lower portion is nothing but a tank over which the rhombus shape is nothing but the, what we can say, the filter. The filter line is connected to the pump. The pump is connected to the relief valve. From the relief valve, it is connected to the solenoid operated and also the spring operated DCV valve. Then from the DCV valve, it is connected to the, what we can say, the cylinder 1. Okay, cylinder 1, that too especially at the, what we can say, the pressure P1. Because of the pressure P1, what will happen, the piston will start moving from the piston end to the rod end. The pressure, what it is, P2 is developed at the rod end. This pressure P2 is applied to the, what we can say, to the cylinder 2. Okay, that is the P2 pressure is applied at the piston end. Then again, as a cylinder starts, cylinder 2 starts descending it, the pressure P3 is developed at the rod end. That P3 pressure, what it has been developed, that it is flowing back to the tank, or it may be to the DCV valve. This is a process normally what it is taking place in the case of the sequencing. Normally the sequencing, it is done, that depends upon the type of the load. If the load carrying capacity needed by the, what we can say, the circuit or the system, it should be of the larger. In such cases, we are going for the sequencing, either it may be the sequencing parallel or by series.